I am Susan here. I'm going to moderate, but I want to introduce my wonderful friend, colleague, my crewmate in one of the MDRS missions in 2019, and that's James Burk. And also James is the co-founder, and he's the head of the Mars Society. He's the IT director, and he's been with Mars Society for so many years. And it's about time he has his own crew. So his session today titled MDRS Crew 261 Experiments. James, the microphone is yours. Take it away.
Thank you so much for that warm welcome, Susan. And I also want to echo, it was a great experience being on a crew with you back in Crew 197. You were a great commander for our VR crew, and I can't wait to have that experience again sometime. So thank you, and welcome everyone. My name is James Burk. I'm the IT director of the Mars Society. I've been part of the Mars Society since we were founded in 1998. I'm based in Seattle. And I'm talking to you today about the experiments that we have been working on for my upcoming mission 261. And so this is our crew patch. We've been actually planning this mission for about 2 years. It's all started when I met Aline Ducati from the French chapter, Association Planète Mars. I met her at our Irvine conference in, I think it was 2017, and or it could be 2018, but anyway, we kind of struck up a friendship, and we were originally trying to put an ISRU experiment at the MDRS, talking to Robert and Shannon Rupert and others about how we could do a real ISRU experiment that was a permanent experiment at the facility. And then we talked about, why don't we just do a crew? And so she found some friends over there in France and Belgium, and we put this crew together. And this is our patch. We've also added a couple others since we originally, the 5 of us. This is our patch. It kind of talks about our experiments. It talks about that there's folks from France and Canada and the US, and we've got the Space Needle up in the top right and the Eiffel Tower. We've also got some of our experiments. There's a drone, and there's a little gas dome bubble on the ground, and there's a little rover going around. So let's talk about all that good stuff. And again, here's my crew. This is Aline in the top middle, and Julianne. And in the bottom row is Erin Kennedy, who's a robotics expert. She's from Canada. And Cecile is from, she's French, but she lives in Belgium. She's our green hab officer. Guillaume is a cave explorer, and he'll be our geologist. And then also in the top right is Julian. He's a trained pilot. He'll be our crew engineer. He's actually flying airliners over in Europe right now. And then finally, last but not least, Chris Davidson is our crew journalist. She works with National Geographic, and we added her a couple months ago. Unfortunately, we had to delay our mission. We were originally going to go in December, so we'd been really gearing up to do that all this year, and then we had to delay because of COVID. We had to delay because folks can't fly from France to the US, and we all decided as a crew to delay, and so we're looking now at about a year out, possibly next spring of 2023. So that's what we're looking at now. But anyway, I want to talk to you about our experiments because we've actually been doing a lot of work on these. What we ended up doing is we did a call for experiments from the community, from the Mars analog community. And we had a lot of responses, and we did an evaluation. And these are the experiments that made the cut of our evaluation, but there's also a couple others that we've added. And I'm not gonna have time today to talk in detail about all of them, but rest assured that they're really innovative experiments, and we have some great partners that we're working with, and you see them listed under the third column there as our principal investigators. The Chimera experiment, the physiological garment, that will actually be a talk at our conference this year. And then some of these also have been previous talks. We've talked about Ali Zari's drone work before at our conference. Obviously, MarsCoin. MarsCoin is a cryptocurrency project that the Mars Society is a beneficiary of. And we're certainly, really excited about them. And Leonard Lopin has been a Mars Society member. He was actually a Mars One candidate originally, and back in 2014 he came to our conference and unveiled the Mars Coin project, and we've been partnering with him on many things. The Cosmos experiment is really innovative. There's kind of a theme here of we're gathering data. There's also a theme of helping improve the campus, and also innovative technology. So those are sort of the three themes of all of our experiments. I'm especially excited about the Astrea experiment, which is monitoring the HAB. We're basically going to hopefully turn the HAB, the MDRS main building, into a smart home where we can actually instrument things like the airlock and count down when people are inside it, and gather temperature and pressure readings from across the campus. Also having an infrastructure that we can save data, and have a technical infrastructure from crew to crew where we can actually share information between crews. That doesn't exist now. A lot of times people will come do innovative work at the MDRS, and then future crews won't really benefit from that. So we want to kind of improve that situation with some upgrades. AlgaCraft is a really interesting experiment where we're going to have a spirulina reactor, basically an oil drum full of algae that grows, that we could harvest powder out of, spirulina powder, and it'd be a food source. Also, the Lumetrix, it would be a grow lamp for the green hab. It's a really innovative technology that is being provided by that company, Lumetrix SA. Questionnaires for us, so again, gathering data after our EVAs, answering questions about how we're feeling and what we did. Some extra stuff that we know, every crew does crew reports, but we're also going to have some data gathering activities to try to improve the science of what we're doing while we're there. And then the kite propulsion rover. So Erin was actually a PI, and then we liked her so much we added her to the crew. She was one of the experiments we selected. Her idea is to build a tumbler robot that has kite propulsion. And she's also, now that she's on our crew, she's going to be our robotics expert and help out with some of the other ones. So let me double click on a couple of these, okay? So the first one I'm going to double click on is the VR drone. So this is Ali Zari's project. I've been a partner with Ali for a couple years now. He's part of our MarsVR program, which you guys may know I also help out with MarsVR. I'll be talking about that tomorrow night at the evening session in more detail. But when we first started MarsVR, we tried to scout the MDRS terrain by flying a drone. We actually hired a drone that works, a crew that works a drone for the geology industry, the mining industry, and they flew a fixed wing drone to capture a square mile of terrain, and we actually use that in our VR app. This is kind of a more innovative version of a drone like that, where we can capture 360 video, and it's very high definition video. So we've certainly flown drones at the MDRS before. We have drone footage of flyovers, but this is sort of next level stuff where the drone not only takes really high resolution video, but it has some smarts to it. It can actually, you can dispatch it and have it come to your location. We're also going to use it to scout out specific areas that we want to capture in VR and hopefully capture some of that data while we're there. So Julianne and I are going to learn how to fly this drone, and it's pretty much been constructed already. We were getting ready for having this in December. So the prototype is done, and we're going to get basically some training lessons on that soon. So that one's a really exciting one. Next is the Rover Swarm. Okay, so we have two experiments from the group Nexus Aurora. You may not be familiar with Nexus Aurora. They actually won one of our contests at the Mars Society. And they're a really cool group. They're an internet-based group, so there's people from all over the world that go into their chat room on Discord, and they work on a variety of projects for Mars settlement. And so we selected two ideas that they submitted to us during our call for experiments. And the first one here is the Rover Swarm. So the idea would be that you would turn these rovers loose on an area, and they would be able to collect samples. And I believe they're going to have the concept of a base station and several other small rovers that go out and collect the samples and then go back to the base station. So if you've ever played the game Surviving Mars and worked with the drones on Surviving Mars, it's kind of analogous to that. You essentially you're going to go set up a bunch of rovers in a new area that you're exploring. You turn them loose, they go around and swarm and explore, collect samples, and then come back to the main hub. And then you can take that whole unit back to the hab and take all the samples out for analysis. That's essentially the idea here. And they're also working on ways for these to operate autonomously, where we can just turn them loose from the hab and have them explore on their own. So very exciting stuff. And here's another, this is a really recent render I got. I just got some of these images I'm showing you in the last couple of days of what the progress is. So you can see they've gotten some bigger tires now than they originally had. That's based on some feedback I gave them. These are gonna need to operate on dirt roads at the MDRS, and they're gonna have to stay on the road when they're not exploring. So they're building some of the logic in for that. The next one from Nexus Aurora is the farm experiment. And that is essentially a robot farming apparatus. The idea with this is that it's a prototype of how you would grow large-scale agriculture on Mars. It works on a track. It's essentially a rectangle, and the main arm operates on a track. And they're designing this so that you could have this track be like a kilometer long. So you can imagine just having like kilometer or longer rows of crops, where you have this track running down the middle, and the track can monitor and manage the plants that it's growing. And so we're going to basically set this up on a smaller scale at the MDRS. It's TBD if we're going to do this in the Green Hab or do this in the Science Dome, or even have a temporary facility outside that's in an inflatable. But the idea would be that this is a farming apparatus. We're going to grow crops. And you can go out and find systems like this that cost a lot of money, that are robot gardening kits. I did some research on this last year before we started working with Sam and the team, and they're pretty expensive and they're kind of unreliable. So what Sam and his team at the farm at Nexus Aurora are doing with farm is that they're trying to build an open source version of this, and a simple version that could be reused. And so you can see the bottom right or the bottom left screenshot is one of the parts. There's really only 10 parts in there, and you can get all 10 at a hardware store. So they're trying to make this thing really simple and have software and the whole kit being something that's easy for people to replicate. You can see some of the design evolution they've had from the initial concept, and they evolved it to improve stability. So they've been really working hard on this. There's quite a lot of people involved with these last two experiments, and very exciting that our crew is going to be able to be the first to test these out in the field. And then here's a little bit more about that part I was just mentioning. This is from a slide of a deck that Sam just gave recently. Again, 11 parts or 11 drilling operations required, 10 unique components. Most of them are stock. So really not hard to build this if you're good with tools. Okay, the next one I want to talk about is a Mars coin related one. So the idea with this one is that we're going to sort of pilot out a couple of future Martian society things. So we're going to pilot out with the blockchain, with the Mars coin blockchain. You know, Mars coin is not a token. It's a cryptocurrency like Bitcoin. It's not a token like all these random tokens that are out there now that people are trying to pawn off. Mars coin is actually a real cryptocurrency that has its own blockchain, and Leonard and the team at the Mars Coin Foundation are always adding more features to it. So what you're seeing here is a screenshot he sent me this morning of the voting system that they're working on. They're actually working on this right now. And so we're going to have an ability to take polls among our crew, and it's essentially electronic voting that is on the blockchain. So it is immutable. What's the benefit of doing voting on a blockchain versus a normal database like an electronic voting system we have today in the US or other countries? Well, the blockchain, you can't edit the blockchain after you've put information into it. So there's no way to counterfeit votes. That's why Bitcoin is successful as a project for currency. There's no way to counterfeit Bitcoins. They figured out how to prevent that with the blockchain. And so you can apply that to voting, and we could use this as a future Martian society voting system that is fully secure, that's just bulletproof, and is running on MarsCoin's blockchain. We're also going to use a feature to do inventory, and kind of same concept. If you're going to generate resources on Mars and you want to be able to transact them easily, you can store all their information on the blockchain. And you can imagine you can track a resource from the time it was created, the time, and all the times it was transported, all the way down to when it was used. You can track the entire life cycle of a resource. The analogy I like to give for this is if you went to the grocery store and all the apples that you were looking at in the produce section were on the blockchain, you could pick up an apple and it would have a little QR code on it. You could scan the QR code and you could see exactly when that apple was grown, where it was grown, who picked it, how it was transported to the grocery store, and how long it's been sitting on the shelf at the grocery store. That is the power of the blockchain, and there's no way to counterfeit that. And so you can imagine putting that technology into Mars, into future human settlement and economy on Mars. And that's kind of what we want to do. We want to basically have an inventory system at MDRS that we can keep track of where everything is, and it's on the blockchain. And so there's no way to counterfeit that. There's no way to fake it. And the other thing we're going to do is put a node for MarsCoin at the hab permanently, because that just needs to happen. And that would mean that there's MarsCoin, there's a node on the MarsCoin blockchain at the hab, just like someday we'll have nodes on Mars and in solar space around the, basically satellites that orbit the sun, so that you can communicate between Earth and Mars through the blockchain and have the interplanetary internet that people have been talking about for 20 plus years actually be a reality. That's the kind of technology that this is all part of, is MarsCoin and the blockchain. Okay, the last one I want to talk about is HAL v2. So HAL is an experiment I brought on my last crew. So Susan might remember this. This is essentially a touch screen on the wall in the upper deck of the hab that has crew information. And so there's a history of using the name HAL with the MDRS. When the MDRS project was first formed, they had a laptop that they called HAL, and it was the laptop that they wrote all their crew reports on. And there were some other really cool things that it did. It was wired up to the hab in it's sort of an Internet of Things way where they could track certain things in the hab. That's 20 plus year old technology, or 15 plus year old technology, so it's not used anymore. But what I was trying to do when I first developed this system, this new HAL system, is a throwback to that. Is I wanted to have an information display for the crew that they can get information that's important to them during their mission. And also this would be an extensible platform that that new experiments could plug into. And so the first version of HAL was used during our first mission in 2018. And this is what it looked like. This is the exact software we had running on the wall during our mission. It had a bandwidth monitor, because we have a HughesNet satellite internet system at MDRS, and we have to monitor how much data we use. So that's what the bar at the top left is doing, and also showing you how much of the daily allowance you have remaining, and the countdown timer. All that is highly important if you're a crew member. You need to know when you can send your reports and how much bandwidth you have left for the day. Also the local weather in Hanksville, that we were pulling that feed in. Also the daily schedule. I had a system that was connected to Google Calendar, and unfortunately it didn't work when I got out there. It was working great here at my house, but when I got to Utah, we couldn't connect it to Google Calendar because of the internet challenges. And so I actually have a new method to do that now that uses JSON files. So we'll actually have the crew schedule every day for the whole 2 weeks planned out, and we'll have that in HAL, and it'll remind everyone what they're supposed to do at any given time during the day. We also have a system called Mars Chat. where Capcoms, which are the people that are supporting the crew, can actually communicate with a built-in delay that mimics what it would be like to send text messages back and forth to Mars. So at any given point in time, the alignment of Earth and Mars means that an electronic message isn't going to happen instantly. It's going to happen anywhere between 9 and 20 minutes. And then there's times when Mars and Earth are on other sides of the sun and you don't have any communication. And the JPL teams have to deal with that with the rovers and the orbiters right now. And so we basically have a way to simulate that with a chat program called Mars Chat. And this was connected into that. So we actually were able to get messages from Capcoms on this display as soon as they were received, which was great. This uses a Raspberry Pi, which is a small computer, and it uses a touch screen. And it was actually fancy enough that it had not only the touch screen mounted on the wall, which contained the computer, but it also had an additional keyboard, monitor, and mouse. So in addition to it being the crew display on the wall, it was also a general purpose workstation that we could use to write our reports and not use up too much bandwidth, not have a bunch of laptops open so that we were all consuming bandwidth with all the other random things that laptops do. This would be a way to constrain the bandwidth that you have available to you to the minimum amount you needed. So this is me after I had gotten it set up back in 2018 on our last crew. And that's me in the right side. That's me holding the touch screen. And there's the key. So everything you see there, the whole keyboard, mouse, monitor, that's all being powered by that same Raspberry Pi. And then there's me with it mounted on the wall. And then there's me, my reflection in it on the top left. So I'm very proud of this project. One of the things I'd like to do is do some additional upgrades to the whole network around the MDRS. In the last year, we've been able to install some security cameras so that we can monitor the outside and the inside over the internet. Much like you'd have a Ring camera at your home or a Nest camera, we've gotten that wired up. I'd like to go in and do some additional upgrades to make sure we have good network connectivity between the buildings, and also have a file server available for our mission, but also for other missions. And then finally, one last thing I don't have a slide for is I'd like to get Starlink set up at the MDRS, and so had some early conversations with SpaceX about that. It actually went all the way up to chain to Gwen Shotwell. And they're still working on it. They're going to have to actually retask some of the satellites to point at Hanksville, Utah for us. But I don't know the likelihood of that happening before I'm out there, but we're working on that. So anyway, that's the last thing I wanted to mention. Okay, that was it. I think we have time for some Q&A.
Well, first of all, James, thank you so much. That was such an interesting and all those fascinating projects. So we have about 6 minutes for questions. But the first thing I really want to say to everyone here who came in a bit later is that James was my executive officer for the MarsVR in 2018. So when you showed those pictures, I was like, it took me back. I can't believe it's nearly 2 years ago that we did that mission together. But congratulations being commander of your own crew, about time, and you'll be an excellent leader. And so with that, let's open up for anyone who has questions for James. We have about 5 minutes here. You can unmute yourself and just ask the question. While we wait for some questions, maybe James, I'll ask you one question. How relevant and how important do you think analog astronaut missions are, in particular with now opening up civilian space, right? With William Shatner just the other day, went into space on the Blue Origin rocket. How do you see the relevance of astronaut training?
Well, there's a lot of relevance, I think, for analog missions in the current environment. I mean, at the Mars Society, we've been at this for 20 years plus. I mean, we started Flashline in the Arctic in 1999 and the MDRS in 2001. So, researching the human factors challenges is something we've been working on for quite some time. And I think it's highly relevant to continue to do that. there also can be better simulations of what it's going to be like on Mars. We can actually simulate some of the technology and equipment that we're going to need on when we settle Mars. We could do that at facilities like the MDRS. And so I think it's highly relevant. And it's a discipline that's in its early stages. Even though we've been at it for 20 plus years, we're just getting started with analog missions, I think. And there's a lot there. It's a very deep field and a multidisciplinary field.
Yeah, absolutely. I concur. So there are several questions. Stuart Nelson asked, I'm not quite sure if it's pertaining to MDRS, but the question there in the chat says, how much land is there? Is there room for a large, oh, sorry, somebody moved up. Is there room for a large habitat in the future? So I'm assuming he's referring to MDRS.
We're on leased state land.
Okay.
And we have
I was not aware of that.
mile.
1 square mile.
Of which
Okay.
40 acres is the campus. Sorry.
No worries. Glad to hear you, Shannon. All right. Any other questions?
Yes. There's another question. Casper asks, is anyone working on creating low pressure, low temperature, and high radiation analog environments?
Oh, wow. That's a good question. I am not aware of that. I know that there is work being done in other countries. Like I know China, for example, has a pretty extensive analog base in the Gobi Desert. I'm not aware of anyone doing that level of simulation, though. Okay,
so another question from George, and he asks, is the Mars Society looking at a larger analog anytime soon to accommodate a larger crew and longer stays? And then he wrote Russia is doing that.
We are not currently looking at a larger analog with more larger crews. I think what we have with MDRS is a lot for us to keep going and make sure that we're doing it really well. And so that's kind of what we're focused on right now. I'm sure Shannon would agree with what I just said.
Yes, I do.
I do.
By the way, just for those who don't know who we're referring to, Shannon Rupert's here. And hi, Shannon. And Shannon is the director of MDRS, the Mars Desert Research Station. Just want to introduce you, Shannon. And so Priscilla Thomas asks, what type of medical and psychological challenge studies might be on deck in the MDRS near future?
Yeah, that's great. That's a great question. And we do have a couple. I mentioned we have an EVA questionnaire. We have some medical monitoring that we're doing, and other crews like ours do research like that. Every crew kind of does its own set of experiments. And so there's been crews that were all doctors, you know, wilderness medicine crews. There's been other crews. I know Inga Popovich, or Popovite, sorry, was just at MDRS, and she's a sociologist researcher. And so she looks at really interesting research on the power dynamics between crew members. And so, you know, and I know she does a crew diary experiment, which I think they did on their mission. So there's definitely a lot of work like that happening already and will continue to happen.
Great. Another
and
question.
any of those types of studies
Jen.
require an IRB. Any
Yes,
type
an
of
IRB.
medical and psychological studies require an IRB.
Yep.
And just for those who don't know the acronym, IRB stands for Institutional Review Board. And so Darian Phillips asks, what's the main power source in MDRS?
That's a great question. We have a solar panel array. That is the main power source. And then we also have a generator. And I believe we just recently got a newer generator. And that's sort of the backup source. And that was originally the only way we did power was a generator, but now we've had the solar array now for a few years. So.
Wonderful. So we're at the top of the hour, and I think we are ready to close this Zoom room. But let's all say thank you so much, James. That was really a fascinating presentation and wonderful projects that for myself, I would love to connect with you. But anybody who wants to connect with you, James, how do they communicate with you?
I'm all over the internet, but they can email me on my Mars Society account. I just put it in the chat there.
Fantastic. Thank you so much, James. Thank you, everyone, for joining, and we will see you in the next session. Take care.